Okay, so this is part two. Now what we're ready to do, now that we've kind of covered in behavior, or finding our x-intercepts and talking about multiplicity and how that kind of looks when you touch or cross the graph. Now we're ready to go ahead and put this all together. So right here, we are going to graph each polynomial using these guidelines. No graphing calculators, so we want to kind of avoid those. You can use a regular calculator if you like. And so we're going to start by using the leading coefficient test to determine the graphs in behavior. Then we're going to find the x-intercepts. Then at each intercept, determine whether the graph crosses the x-axis or touches the x-axis and turns around or bounces off. You might see some different terminology. And then find our y-intercept, because usually that's an easy point to find that can kind of be helpful in trying to graph this. And then part D, this is something we haven't really done yet, is find, if necessary, find a few additional points of the function. So, okay, so what we're going to do here is we have to find all this information, and what we're going to do is we'll plot our x-intercepts. And once I hit my last x-intercept to the right, that's when my right in behavior will happen. I either go up or down, right? Same thing with my x-intercept on my left side of my graph. The last one to my left, there's not going to be any more ups or downs. You either go up or you go down. It just kind of depends on that end behavior. Okay, so starting with this first one, it's already factored for us, which is helpful, but it does add one little extra thing we have to do. So it's nice that it's factored for us, but now we have to figure out what that leading term is. We have to find the leading term. And so I did one in the previous video, and the way it works is you just look at each factor, and it's not super difficult. What you do is you take each factor, and so that first one's just an x. Then the second one's x plus 2 squared. So all you do is apply that power to the variable term right there, the variable term with the highest power, which there's only one. And so that would become an x squared right there. And then here, all we have is an x. So then I'm going to multiply that together. So when you multiply those all together, my leading term would be x to the power of 4. Now, why do I need to know that? Well, that's going to help me figure out the end behaviors. Because now I know what the leading term is, the term with the highest power. Now, if you really wanted to, you could go ahead and, FOIL this and then multiply that with this and then distribute the x. That'd be a lot of work. And what you would find out is that the leading term would be x to the power of 4. So you're going to figure that out anyways. And then you'd have to refactor everything, right? So this is just like a shortcut to figure out what would be the leading term if I did have to multiply this all together. I don't want to multiply it all together, and so that was kind of the shortcut. You take each term, and then, so if this would have been a power of 5 or whatever, then I would have taken x to the power of 5, and so on. And so you just multiply those together to figure out the leading term. It's to make your life a little bit easier. So with that information now, with the leading term, I can figure out the end behavior. So as x increases, so as x goes to infinity, as if I plug in positive x values and raise it to the power of 4, I'm going to get positive return values. Then, as x goes to negative infinity, as I plug in negative values and I raise it to a power of 4, well, it's even Steven. So I'm going to do the same behavior. Plus, think about it. If I plug in negative numbers in for x and raise it to an even power, it's going to result in positive numbers. So basically, this is what I figured out so far. I know there's going to be some ups and downs in the middle, but I know that at the end of the day, it's going to go up to the right and up to the left. And so what I'm tasked with now is figuring out what is happening in the middle part, right? So I know what happens at the extremes, but now I got to figure out what's happening in the middle. So now I have to find my x-intercepts. And so let me go ahead and erase this right here so we can work here. So my x-intercepts, what's nice about this being factored is that's pretty easy to figure out. So I have an x-intercept right here at x equals 0. Then I have an x-intercept right here at x equals -2. And then I have an x-intercept right here at +2. So I have 3 x-intercepts. Now, 0 crosses because it has a multiplicity of 1, and so does 2. At 2, I am going to cross because I have a multiplicity of 1. And actually, they might on your homework have you write them as ordered pairs, so I'm going to do that. Plus, I think it helps maybe give you a little better understanding. So when x is 0, y is 0. When x is 2, y will also be 0. Those are my x-intercepts. Those are on the x-axis. Now, as far as -2, though, that has a multiplicity of 2. And so that means it's going to touch the x-axis and turn around. It's going to kind of have a parabola shape to it. So let's see, when x is -2, I still get a y value of 0, but it gives me a little detail about how that looks. Okay, and then my y-intercept is kind of boring because if you were to plug in 0, what's going to happen here is you're going to get 0 times 0 plus 2 squared, and then times 0 minus 2. What's going to happen is all this stuff is going to, it doesn't really matter because I'm multiplying by 0. So 0 times anything is going to be 0, and then 0 times this is going to be 0. So my y-intercept actually just happens to be at the origin, so that's not going to help me too much. Okay, so let's plot our x-intercepts because I know those. So let's see, I have an x-intercept here at 0, 0. Then I have one at 2, 0, so I'm going to put that over here. And then I have one over here at -2, 0. Now, what I know about my first two is they have a multiplicity of 1 right here. So they're going to kind of be straight lines when I go through it. What I know about my one at -2, 0, it's going to kind of have a parabola shape somehow. And it's actually, I'm going to start drawing my graph because I know my end behavior as I go to -infinity is going to go up. So I know it kind of has a parabola shape. So I know it's going to kind of look like this as it comes down. And then it's going to go up like this. By the way, I should have mentioned this at the very beginning. The homework on this will be a paper assignment that I will give y'all on Monday. But anyways, you will have some homework in the computer on this, but the actual graphing part will be a paper assignment. So you might notice that if you get a head start on the homework on this. Okay, so sorry, I just wanted to mention that while I was thinking of it. So I know my end behavior is x goes to -infinity, y goes up. And so see, that's my last x-intercept to my left. So I'm not going to have any more ups and downs. Once you hit your last x-intercept on the left, you either go up or you go down. In this case, I go up. Now, and I had to be a little careful because this tells me that at my x-intercept at -2 right here, this is at -2, that it's going to, that it, you know, it bounces off. So it's going to kind of have a parabola shape. So I don't know exactly how this is going to look, and I'm going to erase this in a second, but it's going to kind of go up and then come back down right here and then go down and then come back up. Now, I don't know exactly how that looks, so I'm going to go ahead and erase that now because I am going to want to be a little careful. I'm probably going to plug in some points to figure out how high and low I go. But that's generally how it's going to look, what I just had up there. Let me put that back up there. So I know that, see, I'm going to bounce off and then come and I go straight through at 0, 0. And then I'm going to dip down, but then go back up and then go straight through at 2, 0 and kind of go up. I should have drawn this more going to the right. But anyways, going up and to the right. So, yeah, that's pretty much how it's going to look. But now, just to be sure I'm accurate, what I'm going to do is I'm going to find those additional points. That's part D. And so what I'm going to do is I'm going to go ahead and figure out, okay, what would I get at -1 right there? So I'm going to plug in f of -1. So I'm going to get -1 times, let's see, -1 plus 2 squared, and then -1 minus 2. So I'm plugging those x values in right there, and I'm just evaluating the function at -1. So let's see. Well, this is just -1. This would become 1 squared, and this would become -3. And so let's see. This would just be a 1. 1 squared is 1. And so when I multiply all this together, -1 times 1 is -1. This would give me -1. And then -1 times -3 is +3. So when x is -1, y is +3. So I'm going to go up 1, 2, 3. So now I have a pretty good idea of what happens here. So I know that this is going to kind of go up, but remember, no sharp turns. You kind of want everything to kind of be nice and smooth. And then we're going to go back down, but now I don't really know how far to go down. I might go down a little bit. I might go down a lot. I'm not really sure. So what I'm going to have to do is now evaluate the function at +1. I'm going to evaluate the function at +1. So I'm going to do f of +1, which would be 1 times 1 plus 2 squared, and then times 1 minus 2. And let me scroll down so we can see this. And so I'm going to have to do this math. I'm going to kind of work it to the right so that I don't start to get into the problem below me. So let's see. Well, I'll work a little bit right here. So let's see. This will become a 3 squared. This will become a -1, and then I still have 1. So then what will happen is I'll get 1 times 9 times -1. And so 1 times 9 times -1 actually gives me a -9. So I'm going to dip down a lot further than how I went up on the other side. So you just kind of have to be careful here. There we go. So I got to dip down to 9. Okay, so well, I already have this tick mark here, so I'll go ahead and label this as -5, and then I'll go down a little bit further and label this as -10. So I need to go all the way down to -9. And so here we are. So I'm going to I'm dipping down. So I need to dip down to about right there. So dip down, and then come back up. And then I go through that, and then, yeah, I need to go a little bit more to the right. There we go. And there we go. That's our first one right there. Okay, so just kind of recapping, most of them we're going to have to factor. This one we didn't have to factor. It already was factored for us, which was nice. But then we did have to figure out what the leading term was so that we could figure out our end behaviors, right? And figuring out the leading term, don't overthink it. X times x squared times x. That's all it was, okay? Don't overthink about how you find the leading term. It's not really that bad, okay? Now, if there would have been a number in front right here, you would include that whenever you're figuring out the leading term, okay? But anyways, hopefully you don't overthink that too much. But most of them are going to look like the next one, where you actually, it's going to be in general form, and you're going to have to do the factoring to figure your x-intercepts out. So I'm going to go ahead and scroll down so we can look at it. All right, so on number 2 right here, the leading term, I know what it is. I don't have to do anything to figure it out. I already know what it is. It's right here. So since it's positive, my right-hand behavior will be positive. Since it's an odd exponent, it's going to be the opposite when I go to the left. Okay, and then also take a minute, just kind of think about it. If I plug in a positive number, I get a positive return value. If I plug in a negative number for x, I'm going to get a negative number in return. Yes, all this other stuff is important. That's going to help us with the next part, part B, which is finding the x-intercepts. So that's what we're going to do next, is find our x-intercepts, and by doing that, you let y equal 0, or in this case, f of x equals 0. So let's see, we're going to have x cubed minus 3x squared minus x plus 3. Okay. Oh, let me set that equal to 0. Okay, now we're going to factor this. And you're like, well, wait a second, I don't see anything that factors. Well, whenever you have 4 terms, most of the time you can probably do factor by grouping, and that's going to be the case on this one. So I'm going to group the first 2, and they have an x squared in common that I can factor out, and that will leave me with an x minus 3. On the second set, that's weird, I got the opposite. So in order to cause a sign change, I'm going to factor out a -1, and it will change this into x minus 3. And what happens is I get that match that I need in order to finish the grouping process. So what this allows me to do is factor out that common group of x minus 3. So the x minus 3 is going to get pulled out of here. So the x minus 3 gets pulled out. And my other factor is going to be what was left over, the x squared minus 1 equals 0. Okay, and then the x squared minus 1 is factorable. So that's the difference of 2 squares. So I'm going to factor that into x plus 1 and x minus 1. Okay, so stuff we've all done before. So now I'm going to go ahead and list them, and I have to figure out, do they cross or do they touch? And so they all have a multiplicity of 1. They all have a multiplicity of 1. So guess what? They all are going to cross, and they're all going to be pretty straight when they cross. They're all going to kind of just be straight lines that kind of cut right through. And so let's see, we're all going to cross. So at 3, 0 we cross, at negative 0 we cross, and at 1, 0 we cross. So we cross at all those. We don't have any that bounce off. Then my y-intercept is actually really easy, because if you plug in 0, everything's going to go away except for that 3. So when I let x equals 0, y equals 3. So that's nice. That's an additional point that might be helpful. Okay, so now what we want to do is go ahead and plot our x-intercepts. So let's see, we have one at negative 1, at positive 1, and at positive 3 right here. Okay, and so they all cut through. So my end behavior, if you look here, as x goes to infinity, so we're going to have ups and downs, but as I cut through my last x-intercept, it's going to go up indefinitely like that. And so you can just kind of draw a straight line kind of like that, kind of tilted to the right. And then as I go through my last x-intercept on the left, I'm going to be going down to negative infinity. So once again, you can just kind of draw a straight line going down. Now what's different here is I don't have to have that parabola shape like we did on the one up above, because all my x-intercepts cross. They don't touch. They don't touch and turn around. They just cross right through. So once again, what I'm going to do is I'm going to kind of do a rough sketch, but then I'm going to erase it, because then we need to really figure out, well, you know what? I do know in one other additional point. I know 0, 3. So let's see, 0, up 3. So I know I'm going to go up to this point right here. So I'm going to go ahead and draw that part of it. So I'm going to kind of, it's going to kind of curve up here, come back down. And then at this point, I don't really, I mean, I know what it generally looks like, but I'm not sure exactly how far it's going to dip down. And that's what we're going to figure out in a second. But like I said, if I were to do a little rough sketch, it's probably going to go down and come back up like that. But I'm going to erase that, because I want to make sure I'm accurate. And so what I'm going to do is I'm going to go ahead and figure out, okay, well, what is the y value when x equals 2? Because maybe I just dip down a little bit, or maybe I go down really far. I don't know until I actually plug in the point. So that's what I'm going to do. I need to figure out what f of 2 is. And so I can plug it into the original function if you want. You could plug it into the original, but this is something we're going to do in a later lesson that you'll see that makes our life easier. This right here, this factored form, it's the same thing as this. Those two things are the same thing. And so sometimes it's just easier to plug in your x value here. The math will go a lot quicker than having to raise it to a power 3 minus 3 times, x squared and so on. You can do that if you want. You're more than welcome to. But like I said, in lessons we're going to see next week, you'll see that really, plugging it into the factored form is actually going to be faster. So I'm going to plug in my 2 everywhere I see x in this factored form. So it's going to be 2 minus 3 times 2 plus 1, and then times 2 minus 1. Okay, well, let's see. 2 minus 3 is negative 1. And then let's see, 2 plus 1 is 3. And then let's see, 2 minus 1 is 1. And so let's see what we have here. So if you multiply this together, let's see, negative 1 times 3 is negative 3. And then negative 3 times 1 is, well, negative 3. And so we're going to dip down 1, 2, 3. So we're going to dip down about right here. And now I can finish off my graph and feel confident with how that looks. Okay. All right, so this video is already almost about 20 minutes. I try to keep my videos under 20 minutes. So I'm going to go ahead and stop here and make a part 3.